Hello Internet, my name is Fahim and today we'll see how we can write a code for the BFS algorithm in C++. So let's begin. Step 1, as usual, open up your favorite IDE. You can select a new source file or a new project. I'll just select a new project, empty project, give it a project name, say BFS. Okay, and save it. Okay, after that what you need to do is we name this thing as bfs.h, and what you also need is a new file and rename it as okay, now we're ready to go. So in the source.cpp, what you need to write down is something like this. What just happened? Okay, after that what you need to do is you need to write down some codes for the bfs.h. okay, so for that what you need to write is something like this. Include list. Okay, namespace std. After that what you need is a class. Okay, so the class will be named Java in this. Sorry, the class will be named graph or anything like maybe BFS something. It will have some private elements such as after that what we need is some public elements such as graph, just a default constructor, then another constructor. After that what we need is a destructor, okay, and okay, so oops, okay, So that's our destructor. After that, what we need is, we need to add some edges in our graph. For that, what we need is pushback v, and okay, what we can do is take another variable. For example, root is directed. Okay, so, and let's just set it by default. So if is directed, so not is directed, will add the reverse edge, which is pushback u. That's how we can maintain the graph for both directed and indirected graphs. And finally, what we need is void okay, so that's quite basic stuff. After that, okay, let's just write down some codes inside here. See that capital V in here? We are initializing it inside here. Then we can also initialize this thing here, and then what we need to do is new vector okay, and that's quite pretty much like it. Okay, and finally what we need to do is complete this BFS, this code for the BFS. So for that, visited equals to new boolean v for I equals to 0, I less than v, I plus plus visited I equals to false. Okay, next what we need to do is we need a queue. Okay, because in a DFS graph we can use the stacks and we can use the queue in BFS. So that's why we need a queue, and I'm going to use the list. Next what we need to do is something like this. Here S is the starting point of your graph. Say for example, if this is the S point where your algorithm will start, then you will have to provide S as the input. Okay, so after that what we need to do is visited S equals to true. QE dot pushback S Well, our queue is not empty. What our code should do is something like what happens in the BFS algorithm, which is say int say integer node equals to front seek out okay. After that we have to pop out the first element in the in our queue. After that everything that is connected with the node n have to be inserted inside the queue, and that's why for but we have used the factors in this case. So first we need is a factor typed iterator. That's the standard way of using the for loop in case you're working with factors. So factor int iterator I. So for I equals to adjn dot begin I is not equals to adjn dot end I plus plus if visited star I equal false. What we will do is something like this: visited star I equals to true. You dot is back star I. Yeah, that's pretty much, I think. Okay, so after that what we're going to do is get back to our source.cpp, and what I'm going to do is something like this. See out enter VE. V stands for the number of total nodes and E stands for the number of total edges. Okay, so and remember we had used the add edge. Here we have used this thing. So if you like, you can you can also enter is directed. Okay, so just for simplicity, I'm taking this integer type, but you can manipulate it accordingly, by taking a boolean variable, something like that. That should be simple. I'm just going to go through quickly. Graph G G dot is directed equals to is directed equals to true. In that case, it will be true. And since by default it is false, so else okay, so that's good enough. After that, what we need to do is okay, u and v c in u and v g dot add edge. Okay, right, now that we have our edges selected, we can insert, we can run the BFS algorithm. So okay, and we can also specify here, we should specify it over here, IPS we should enter the starting point, and finally we are ready to implement our BFS algorithm. So okay, now looks good to me. Let's run it. Compile and run. What's wrong with this thing? Off. Okay, so looks good to me. Let's just say we're going to work on this, graph. But here we have, s characters. We want integers. Okay, so I'm going to take a screenshot. Go to Paint. Okay. Select. And crop it. That looks good enough. And now I'm going to take my paintbrush, and so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, So we have total 10 nodes, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 edges. So the first thing that we need to enter is VE is directed. Okay, so 10, 14, 1. Now enter the edges. Okay, so let's see, 0, 1, 0, 1, 0, 2, 0, 3, 1, 2, 2, 3, 1, 4, 2, 4, 2, 6. After that, 2, 5, 2, 5, then 4, 5, 5, 7. Okay, now 4, 6, 5, 7, and finally 6, 7. No, not finally. Yes, now finally 8, 9. Enter starting point. That's 0. And the answer is 1, 2, 3, 4, 5, 6, 4, 6, 5, 7. Okay, that's quite good enough, because I think the answer is correct, because see that here 8 and I am absent, which means 8 and 9 are absent, and similarly here 8 and 9 they are absent. Also we can check it in this way. BFS works like level wise. So that's the level 1, then there comes the level 2, which should be this part, and finally this part. Okay, and in this case, and of course the starting point 0. So first we have 0, then in any order A, B, C can come. That's 1, 2, 3. Next in any order 4, 5, 6 can come, and we also have 4, 5, 6 here, 4, 6, 5, and finally 7. So that's how we can conclude that our algorithm is working correctly. So that's how you can write down the codes for BFS algorithm. And that's it for today. I hope you enjoyed the video. Thanks for watching and have a nice day.